In electrical systems, reactance is an element's opposition to the change in either current or voltage due to that element's capacitance or inductance. Reactance has a very similar effect on AC circuits comparable to how resistors work in DC circuits, and so the implementation of reactance is therefore similar as to how resistors can be used to create circuits that can complete complex tasks. The two main components that use this property are capacitors and inductors. A capacitor is a passive electrical component that temporarily stores electrical energy in the form of an electric field. It achieves this by using two parallel plates separated by a thin dielectric material. As current flows into the capacitor, positive charge builds up on one plate and negative charge on the other, which then creates an electric field that has stored energy. For a capacitor, this built-up electric field resists the change of voltage across that element, creating a reactance. In AC circuits, as the voltage is constantly changing, this translates to a constant opposition to the voltage, creating what has the same effect as a resistor would in a DC circuit. The way that reactance in a capacitor can be calculated is by using the formula 1 over 2 pi Fc, where C is capacitance in farads and F is the frequency of the source. Inductors are similar to capacitors in the sense that they store energy, but instead of an electric field, an inductor uses a magnetic field created by a wire coil to achieve this. The way an inductor functions is very similar to that of a capacitor, in that as current flows into the inductor, it stores energy in the form of a magnetic field. A property of magnetic fields is how they oppose any changes in their flux. So as AC current is constantly changing the current through the coil and therefore the amount of flux, the stored energy in the field acts to oppose this, creating a reactance and has the same effect as a DC resistor. The way reactance of an inductor is calculated is by the formula 2 pi FL, whereas before, F is the source frequency and L is the inductance, measured in henries. Reactance is a component of a circuit's total impedance, which is a circuit's opposition to voltage and current, with the other component being that circuit's resistance. The importance of reactance cannot be overstated. As a major factor in how AC circuits function, much of modern-day electronics rely on how this property of capacitors and inductors impacts a circuit.